Hello friends, I'm Dr. Manoj Singh, Head of Department of Zoology at Kalinga University. Today we will be going to the third ecological class. It is on niche hypothesis. So what is a niche hypothesis? So before going into the detail, I'll just today we'll be covering the basics type of niche, that is fundamental and realized niche. What is the principle of competitive exclusion? What is the difference between the realized niche and the competitive niche? What is character displacement and what is adaptive radiation? So we'll be going to all these topics today. So first we should just get into the history of this concept, niche hypothesis. So there have been a lot of studies on this particular concept, and different scientists have given their different definitions of niche. Like for example, Alanton, who in 1927 defined niche as the subdivision within the trophic grouping of organisms, and he divided the organisms into carnivore, herbivores, omnivores, etc. Then another definition came by Krebs in 1994. He said he gave the emphasis on the role of an organism in that particular environment and how that organism is actually acting and how its relationship with the surrounding community. So on the same note, Begon in 1986, he considered the important environmental factors as the limiting factors due to which a particular individual of a species or a group of population responds to a particular condition and how they survive and grow and reproduce in a particular habitat. So there have been a lot of different type of definitions on the concept of niche, and to summarize, give you a general statement on niche. Niche is nothing. Niche is particularly a type of a habitat in which an organism is found. So there are two types of niche. One is fundamental niche, another one is realized niche. So what is fundamental niche and what is realized niche? So the difference between these two niches are, the fundamental niche is that particular area or it is a large area of any habitat where the probability of finding an organism is possible, or where you can find where an organism can be found. And it is mostly based on the interaction with the physical environment, and is always it is occurring in the absence of any type of competition. While in realized niche, that is it will be part of the fundamental niche, and it will be found after the species is interacting with other adjoining species, and in that particular habitat the competition will be an important factor. So for example, to understand this thing, we can say that suppose we assume this particular room as a niche. So an organism can be found in every corner of this room. So that becomes a fundamental niche of that organism. But if we observe that particular organism for a longer time, we will find that the organism is restricted to particularly only one corner of the room. So that one corner of the room becomes the realized niche, where the organism is found maximum number of times, and at that place it is interacting with the adjoining species of that particular corner. So in a nutshell, we can say that the realized niche is very much part of a fundamental niche and is smaller in size. On the same note, we have this specialized habitat occupancy, where there is two different type of distribution, where there can be, like on the basis of temperature variation, there can be stenothermal organisms or there can be euthermal organisms. So stenothermal organisms will have a very limited temperature range of adaptation, and they will be found at a very particular restricted area where a suitable type of temperature is found, while a eurythermal organisms can be found in a broader range of temperature varying region. With this we can understand by we can take the example of reptiles in case of stenothermal organisms, where these reptiles are found in a very restricted area where we have a normal atmospheric temperature ranging from 20 degrees Celsius to 25 or 30 degrees Celsius, because since they are the exothermic organisms, and they can be found in a limited thermal region, while endothermal organisms like us, we are where we can be we can stay at a very versatile areas, like we can stay in higher mountains, we can stay in along the coastal areas, even in rainforest, so we can tolerate a broader range of temperature variation. So we are eurythermal organisms. Coming to another concept of niche hypothesis is a principle of competitive exclusion. The first definition of this was given by J. Guerenel in 1915, in which he stated that two species which are approximately requiring the same type of resources are not likely to be habituated in a same habitat for a longer time. Either one of the species has to move out of that particular habitat, and this was further been refined by Gauss, who was a mathematician who formulated a formula known as Gauss theorem in 1930, and he said that the loser species, or the species which is weaker, will be excluded out of that a particular habitat by the stronger species, and this gives the rise of competitive exclusion principle. Now, Gauss did an experiment on yeast, where he tried to grow two types of organism in a media. One was Paramecium caudatum and another one was Paramecium aurelia. And what he found that when they were growing in separate media, they were growing and flourishing very nicely, and the graph which was found to be logistically growing, and after they were reaching to the carrying capacity, the graph was leveling off, and the population growth was stagnant or stationary. While when we bring in both the species in the same media, Paramecium caudatum and Paramecium aurelia, then at that time what happens that the Paramecium Paramecium caudatum will be diminished and aurelia will keep on growing. That means Paramecium aurelia excluded, or it competitively excluded, the Paramecium caudatum from that media, and the caudatum was vanished out of this, or it was completely moved out of the media, and all the media was dominated by aurelia. So this is called competitive exclusion principle. So if we talk about the definition, competitive exclusion principle states that species which are completely competitors that and are existing in the same niche may not survive or may not exist there for an indefinite time. So this is the basic definition of competitive exclusion principle. Now there are a few important points. So what is the what is the result of this competitive exclusion? There will be sort of a refuge type of areas which will be present in the vicinity or in the peripheral regions of that habitat, where the losers will be migrating and habituating that habitat for their survival. And if certain type of disturbances occur in that particular habitat, that may give a chance to the losers to reoccupy the main habitat, and the earlier winner may be moved out of that habitat. So this is sort of assumptions which, or these are sort of the outcomes also of competitive exclusion principle. Now another concept comes into this is niche partitioning. When there is a very huge competition for resources in a particular area, Then this competitive exclusion principle can give rise to a niche partitioning thing, in which the overlapping species will partition their niches in in the same habitat. For example, there is a very studied, known study done on reptiles, especially lizards, in which different type of lizards were studied, which was habituating a tree habitat. And in that, the researchers found that different species of that lizards were occupying different part of the tree. Like some were occupying the trunk portion, some were occupying the top canopy area, some were roaming around in the ground on the root, you can say on the bottom of the tree. So this is called niche partitioning. The niche is same, but the species have partitioned their niches. Some means they are occupying different part of that niche. Now, this competitive exclusion principle can also give rise to another thing, which is called character displacement. And this character displacement was given by Brown and Wilson in 1956, where where they said that the sympatric species can give rise to morphological divergence. Changes in morphology due to which their niche overlapping, or you can say the competition for the resources reduces in that particular habitat. So this a very well-known study is on the Geospiza fortis and Geospiza nirosteris, which are two species of similar to house sparrow. And these species, they modified their beaks according to for overcoming this niche competition, or you can say they resulted into character displacement of their beaks for avoiding the competition at that particular habitat. So another concept which comes due to this competitive exclusion is niche compression. Sometimes the species compresses their niches to accommodate more number of species in particular habitat. So in this, you can say that niche compression is nothing. It is a sort of a competitive refuge like area or a particular portion of that habitat, where the species themselves restrict themselves for their resources. Like a very good example on this is two different species of house sparrows. We know, like one is Passer domesticus, which is a common house sparrow. Another one is Passer montanus, which is hedge sparrow. So now, when these two sparrows, when they are found in the mainland of Europe or Britain, there they are found to be the Passer domesticus is used to be dominating in the urban habitat, where the Passer montanus is dominating the rural habitat. But the same species in another area known as Sardinia, there they have there is a completely niche crossing over, where the Passer domesticus is dominating in the rural habitat, while the Passer montanus is dominating in the urban habitat. So this is sort of a niche crossing over, where the species, when it is found in a different type of habitat or in a different condition, they are actually crossing over their preferable niches. So with this, I will like to summarize. So today we studied about the niche. What is niche partitioning? What is niche compression? What is niche crossing over, which is arising due to competitive exclusion? Thank you so much.